Hey y'all! Today's lesson is the surface area of prisms. So just a little vocabulary, we're going to be talking about solids, and a solid is a three-dimensional figure. A 3D figure. So a square is a two-dimensional figure, and a cube is a three-dimensional figure. So when we're talking about solids, we're talking about three-dimensional figures. And it kind of breaks into two categories. There's polyhedrons and non-polyhedrons. So a polyhedron is a solid that has all flat surfaces or flat faces. Flat surfaces and flat faces, meaning they're all straight. And the two polyhedrons that we will talk most about, there's more than two, but the two we'll talk most about are prisms. And we're going to talk about rectangular prisms and triangular prisms, and pyramids. Now, a rectangular prism, a triangular prism, or any kind of prism, they have to have two bases. That means one on the end. They have bases, two bases on the end. A pyramid has flat faces, all flat, no curves. But a pyramid only has one base. And so a pyramid can have a triangular base, it can have a square base, it can have a rectangle base. But a pyramid only has one base, and a prism has two bases. And they all have flat surfaces. Now, non-polyhedrons are three-dimensional figures, solids that have curved, they have curved faces or curved edges, circles, or ovals or something like that. And the three that we're going to talk the most about are cylinders, cones, and spheres. So a cylinder has two bases, and they're circles. So on a cylinder, the top and the bottom or the ends are circles, and that's a cylinder. A cone has one base, that's a circle. So a cone has a circular base, and then it comes up to a point where it goes down to a point. And then a sphere is kind of like a ball. A sphere doesn't have a base at all. It means the definition of a sphere is points that are equidistant from the center. So if you could find the center of a ball and then all the points, the front, the side, the back, but that's what makes a sphere round, is every single point that's on the outer edge of the skin of the ball is equidistant from the middle. And so that's the definition. So here's some vocabulary. We're going to be talking about prisms today, but prisms fall under the polyhedron, and these are all three-dimensional figures. Okay, so example 1, classify the solid and then count the faces, edges, and vertices. So the way you classify a solid is first you classify it by, is it a prism, or is it a pyramid, or is it a polyhedron or a non-polyhedron. So for this, it only has one base, and this is a prism because it has all flat, straight edges. There's nothing curved. So this is a prism. It's a polyhedron, but it only has one base. So this is a pyramid. And you name a pyramid by the base, and this base has a square, so this is a square pyramid. That's how you classify it. The type of base, and then is it a prism or a pyramid, or is it a non-polyhedron? Faces are the flat sides, basically, of the shape. So for this, we have the four faces that go around the side. So like here's one, there's two, there's one on the side, and then there's one over here. So 4 faces plus the bottom would be 5 faces. Don't forget to count the base. Edges are these lines right here. So I'm going to highlight that blue. An edge is where two faces connect. An edge is where you take two faces and they connect and they make that line. So we have 1, 2, 3, 4 along the base. And then we have 4 for the 4 faces. 1, 2, 3, and then this dotted line right there. So 8 edges. 8 edges. And vertices are going to be the point where 2 or more edges meet. And so the vertices are like the points of all of the shapes. So we have 1 at the top, and then 2, 3, 4, 5 vertices on this square pyramid. Okay? Example 2, we need to name this. Now, this shape has 2 bases. The bases are going to be like the ends. Sometimes it's the top and bottom, sometimes it's the side. Now this has 2 bases. We have a triangle here, and we have a triangle over here. Do you see that triangle right there? So because it has two bases and they're all flat surfaces, flat edges, this is a prism. And then we name it by its base, and its base is a triangular prism, because here's the base. Now we want to count the faces. So the faces are the flat, two-dimensional shapes, or the two-dimensional drawings on the shape. So we have a triangle in the front and a triangle in the back, so that would be two faces. And then we have this long face, this bottom face, and then this back side face right here. So 3 around the middle, and then two bases would be 5 faces. Edges are the lines where two faces meet. So you can see I have 3 right here around the triangle. So I've got 3 on the front triangle, I have 3 on the back triangle. And then I've got 1, 2, 3 edges. So it would be 9 edges altogether. And then vertices are the points where edges meet. So I have 1, 2, 3 vertices, and then I have 4, 5, 6 vertices. So 6 vertices. So a little bit of vocabulary about faces, edges, and vertices. All right. So the key concepts for surface area. The net of a shape is like the three-dimensional figure has been unfolded and drawn as a two-dimensional shape. Now this is a net for a triangular prism, but you can see you have a base right here. You have the two bases are on the ends, and then these are the lateral faces. That's what we call them, the lateral faces. That means like the middle part that makes up the prism. The two bases, and then you have your lateral faces. If you wanted to find the surface area, or the key concepts for surface area. If you wanted to find your surface area using a net, you would find the area of all the individual pieces. So this is a rectangle, so you would do length times width. And if this is a triangle, you would do the area of a triangle, 1/2 base times height. And you would add all this together to find the surface area, because the surface area is the area all around. But if you don't have the net and you just have a shape, I would recommend you use the formula. The formula for surface area is 2b plus pH. I'm going to explain that to you. This is surface area equals 2b plus pH. 2 means you're going to multiply it by 2 because there are two bases. The front and the back, or the top and the bottom. There are two bases. So that's why it's two bases. Capital B is the base area. So it says capital B for a reason. It means the area of the base. Not just this line right here, not the baseline, not the same as this B, but the area of the base, this triangle. And you multiply it by 2 because there's two bases. And then we're going to add to it P. P stands for perimeter of the base. So the base perimeter, whatever the base is, the perimeter of the base, or like this one, the perimeter of the base, and then the height of the prism. The height of the prism. The height of the prism can only be determined if the figure is standing on its base. So for example, in this shape, this is the base. The height would be right here because you would want to visualize this triangular prism up standing on its base, and it would go like this. So we're going to do some examples, but this is the formula, 2b plus pH, twice the base area, the base perimeter times the height of the prism. And I'm going to show you some examples. All right, so the first two are triangular prisms. All right, you should have these down in your notes. So we'll do this one first. Find the surface area of the triangular prism. I'm going to tell you in class, always start with your formula. 2b plus pH. Now, twice the base area. The base is a triangle. So to do the area of a triangle, it's 1/2 times base times height. Plus the perimeter of the base. So we can go ahead and say the perimeter of the base are these three right here. So 13 plus 13 plus 10. 13 plus 13 is 26 plus 10 is 36. And then the height of the prism is 15. Okay. So now I just need to fill my numbers in here. The base of the triangle is 10, and the height of the triangle is 12, because that's going to make up the perpendicular, the right angle right here. So I have my base times my height plus 36 times 15. And then I would use my calculator when I type this in, and this is 120. Let me switch my sheet. 120 plus 540. And the total surface area is 660 centimeters squared. And because it's area, it actually means if we broke this up into a bunch of squares, that would be the surface area. And I think the bell might be ringing soon. Oh, man. Okay, the bell is ringing soon, so I'm going to have to stop and find another classroom to record.